Hey everyone! If you're struggling with Java's math class, today's video is going to change everything for you. By the end of this tutorial, you'll not only understand the most important constants and methods, but you'll also know how to use them in practical exercises so you can confidently solve real-world problems. Whether you're learning Java for school, interview prep, or your first developer job, mastering these concepts is non-negotiable. Missing them now will make your code more complicated than it needs to be, and you don't want that. So, let's dive in and make the math class simple and usable. Section 1, Math Constants. First, let's talk about constants. These are values that are always available in Java without needing to create your own variable. For example, if you need the value of pi, the math class has it built in. You can access it with Math.pi. This will give you the value 3.14159. And some change. So instead of typing out pi yourself, Java already provides it for you. There's also Math.e, the exponential constant. You might not use it every day, but it's there when you need it, and it works exactly the same way. You just call Math.e. These constants save you time and reduce the chance of errors in your calculations. Section 2, Math Methods. Now let's explore some of the methods in the math class. Power. If you want to raise a number to a certain power, use Math.pow base, exponent, for example. Math.pow 2, 3, 8. Math.pow 2, 4, 16. Math.pow 2, 5, 32. Notice that the result is a double, so you'll often see a decimal point even if it's a whole number. Absolute value. To convert any number to positive, even if it's negative, use Math.abs -5 / returns 5. Think of this as measuring the distance from 0. Negative numbers become positive automatically. Square root. The square root method is straightforward. Math.sqrt 9 / returns 3. This will calculate the square root of any number you provide. Rounding numbers. Java gives you a few options. Round. Math.round 3.14 rounds to the nearest whole number, here 3.0. Ceiling. Math.ceil 3.14 always rounds up 4.0. Floor. Math.floor 3.99 always rounds down 3.0. Finding maximum and minimum. You can easily compare two numbers using Math.max 10, 20, returns 20. Math.min 10, 20, returns 10. These methods are incredibly handy when you need to make decisions based on numeric values. Section 3, Exercise 1, Hypotenuse of a right triangle. Let's put this into practice with our first exercise, calculating the hypotenuse of a right triangle. The formula is C equals A2 plus B2. C equals \sqrt A squared plus B squared. C equals A2 plus B2. Here's how we can do it in Java. Import scanner to accept user input. Import java.util.scanner, create a scanner object. Scanner equals new scanner system.in, prompt the user for side lengths. A, B, C, system.out.print enter the length of side A equals scanner.next double, system.out.print enter the length of side B equals scanner.next double, calculate the hypotenuse. C equals math.sqrt math.pow A, 2, plus math.pow B, 2, display the result. System.out.print on the hypotenuse is plus C plus cm. Quick test, if A equals 3 and B equals 4, the hypotenuse C will correctly return 5 centimeters. Pro tip, always test your code as you write it. It saves hours of debugging later. Finally, close the scanner to free resources. Scanner.close. Section 4, Exercise 2, Circle and Sphere Calculations. Next, let's calculate circumference, area, and volume when given a radius. Prompt for radius. Double radius, system.out.print enter the radius, radius equals scanner.next double, calculate circumference. Double circumference equals 2 math.pi radius, system.out.print on circumference plus cm, calculate area, for a circle. Double area equals math.pi math.pow radius, 2, system.out.println area plus square centimeter, calculate volume, for a sphere.
Double volume equals 4.0 out of 3.0. Math.pi Math.pow radius 3. System.out.println volume plus cubic centimeter. Notice how we use Math.pi and Math.pow again. These formulas are standard, and Java makes them simple to implement. Optional tip: use print to control decimal places for cleaner output. System.out.print area, %.1f square centimeter \n, area. This will display only one digit after the decimal, making your output professional and readable. Alright, that's a wrap. Today we covered key constants like Math.pi and Math.e. Essential methods: Math.pow, Math.abs, Math.sqrt, Math.round, Math.seal, Math.floor, Math.max, and Math.min. 2 practical exercises: calculating the hypotenuse of a triangle and the circumference, area, and volume of circles/spheres. By mastering these concepts, you're not just learning a few Java methods, you're building the foundation for writing clean, efficient, and professional code. Remember, these tools will appear again and again in interviews, real projects, and coding challenges. If you understand them deeply now, future Java tasks will feel effortless. So practice these exercises, play around with different numbers, and make sure you fully understand the logic behind every method. The math class is powerful, it just needed a little explanation, and now you've got it.